Nintendo has officially confirmed key technical specs for the upcoming Nintendo Switch 2, and the wait is finally paying off. On Technology Review, we're diving deep into everything we now know about Nintendo's next-gen hybrid console. And it's not just a spec bump. From a fully custom NVIDIA T239 chipset to DLSS upscaling and a vastly improved GPU architecture based on Ampere, Switch 2 could change handheld gaming for years to come. In this video, we'll cover confirmed CPU specs, real GPU power in docked versus handheld modes, memory details, the system reservation size, and even how Nintendo plans to speed up game load times using a custom file decompression engine, FD. We also explore ray tracing capabilities, DLSS support, screen upgrades, and the surprises hidden in Nintendo's software side choices, like how the docked mode is technically just a performance mode. If you want to understand how this console stacks up, where it improves, and what it means for developers and gamers alike, this is the breakdown you've been waiting for. Subscribe to Technology Review for more real insights into consoles, mobile tech, Apple/Samsung comparisons, and the future of gaming hardware. Historically, Nintendo used tricks like downclocking the GPU during loading screens to boost CPU speeds, and a similar strategy could be in play here. For example, in Switch 1, the CPU reached 1.785 GHz during loading scenes for faster decompression. It's plausible we'll see dynamic scaling across different scenarios again, especially with how Nintendo prioritizes battery and thermal management. When it comes to the GPU, we're no longer dealing with Maxwell-era leftovers. The Switch 2 steps up to NVIDIA's Ampere architecture, pulling design cues from the RTX 30 series. It features 1536 CUDA cores, marking a huge leap from the 256 CUDA cores in the original Switch. Clock speeds are locked at 561 MHz in handheld mode and 1071 MHz when docked. That said, there's a documented upper GPU limit of 1.44 GHz, suggesting more headroom is technically available, though whether Nintendo enables it remains to be seen. One huge change is the dedicated GPU resources for developers. Unlike previous systems, developers don't get access to the full GPU. A portion is reserved by the operating system. However, even with that consideration, the Switch 2 is rated for up to 3.07 teraflops of performance in docked mode and around 1.71 teraflops in handheld. For reference, these are significant jumps over the original Switch's modest performance. And while teraflops don't always tell the whole story, they offer insight into potential. Even more exciting is Nintendo's confirmation of ray tracing support and DLSS integration. The Switch 2 is rated for up to 10 gigaраys per second in handheld and 20 gigaраys per second when docked. This doesn't mean every game will feature ray tracing. It's a demanding feature even for high-end GPUs, but its inclusion in the specs points to future-proofing. As developers become more comfortable with the hardware, expect ray tracing to trickle in gradually. One often overlooked part of gaming hardware is memory. The Switch 2 features 12 GB of LPDDR5X RAM, arranged in dual 6 GB modules. But just 9 GB is available to developers. The other 3 GB is system reserved. This is a larger system share than the previous Switch, which had 4 GB total and allowed 3.2 GB for games. The bandwidth also varies with usage, 102 GB per second when docked and 68 GB per second in handheld mode, showing Nintendo is again optimizing for battery and performance based on user scenario. To keep pace with next-gen games, Nintendo also introduced a hardware-accelerated file decompression engine, FD. The job of this component is to unload compressed files from storage and unpack them into usable memory space faster than a CPU-based method. This should significantly reduce loading times. With 256 GB of onboard UFS storage, plus support for microSD Express cards up to 2 TB, Nintendo has clearly improved storage architecture, both in size and speed. The FD supports LZ for compressed file formats, which are common in games and DLC packages. The display, while not OLED, is still an upgrade. Nintendo is opting for a 7.9-inch wide color gamut LCD panel with 1080p resolution, support for HDR10 120Hz variable refresh rate VRR, and 10-point multi-touch. While some might be disappointed that it's not OLED, the refresh rate boost and wider color coverage make this a meaningful leap. The VRR, however, is currently only supported on the internal display. The HDMI out on the dock doesn't currently support VRR. Whether this changes in a dock refresh is unknown, but it's worth noting. One final note about the system modes. Nintendo's internal documentation no longer strictly defines docked and handheld as binary modes. Instead, docked mode is referred to more accurately as performance mode, which developers can technically enable even when not docked. This suggests there's some flexibility in how game studios use the available power envelope, allowing for more nuanced performance balancing depending on battery or thermal thresholds. Looking at the broader timeline, it's worth appreciating how long the Switch 2 has been in development. Leaks dating back to 2021 align closely with what has now been confirmed. Development kits are now in the hands of game studios, and with games like Metroid Prime 4 and other unannounced third-party titles in development, we're just seeing the early wave. Like its predecessor, the Switch 2's launch titles may only scratch the surface of what the system is capable of. But the key takeaway here is that Nintendo isn't just matching current trends. It's defining a new hybrid standard again. With smart trade-offs, power-efficient design, and scalable performance, the Switch 2 could very well be the most versatile console we've seen. Stay tuned to Technology Review as we continue to explore everything Switch 2, from first hands-on impressions, to dev-focus features, to real-world performance, once launched titles hit the market